showed you in one of the class, like how exactly you can create an intermediate code. Correct. Identifying the particular entries. Now, when should we declare or when should we define or when should we come up with errors? So some errors would be in your first pass of two pass assembler. So those errors probably may be like, for example, if you are talking about, say, in this case, a instruction move. OK, or if I replace this DD by something else. Correct. Then like if like what kind of errors probably might be shown. So let me try generating some errors. So let us say section.data a resd 10 b db 25 40 c dd 193 d db. This is the sample. Okay, so let us see like what kind of errors are shown here. Section dot text global main. Suppose I write only this one. OK, now let us see what kind of error is shown here. So NASM-APLF 32. Now it says there is one error at line number 3. Warning unterminated string. Correct. So if we go and check that line, what is line number 3? Line number 3 is here. Correct. Now if I complete this, say for a while. Now I have another warning. Now, like it says what? It is not having any relationship with what errors are or warnings shown earlier. Correct. This was one thing that it showed. And uninitialized space declared in non-BSS section. That is dot data. So that resd, whatever I use there, if I remove that resd here from here, then ultimately my problem can be resolved. That's what it is trying to tell. So if I now remove it and if I go upon, I can see that the errors are removed. So now for that purpose, now these may be before you are generating the code. Correct. Now suppose if I make few more errors, like for example, correct. Now let us see. Let us try to translate this. So at line number 7, at line number 10, it gives you an error. So let us check what are line number 7s and what are line number 10. Line number 7. So global main. So it says it cannot identify what exactly it is because it knows after main only you are going to write instructions. So this is the stand. That's why the error that it mentioned was instruction expected. Instruction expected. So if I correct one, say for example, if I correct this, I will see still one error because I have written this MAV. So let me go here. Let me correct that MAV. Now still I will get an error. Correct. Still I got an error. Correct. So now if you see, I have showed you a few errors that are shown and what is the pattern? of the error, it shows first the code name, file name, colon, line number as per the source. Then whenever error is error, then what kind of error it is? Is it through parser or is it through something else? Correct. So like for example, above I can see here like what are the error that it showed. It is showing me syntax error whenever there is syntax error. Now while parsing, if I get some error, then that error is categorized whenever I am having this instruction expected kind of error. You can see, you can simply categorize them. Expression syntax error, symbol is ZX not found, instruction expected, instruction expected. Instruction expected is working with the parser error, and these errors are basically kind of simple errors. So before parsing, when you are tokenizing, before parsing, when you are tokenizing, so that error probably could be. But you must have seen like if I don't take into consideration that EZX earlier when I made it as MAV, it was talking about parser instruction. Correct. So that means what? So at the same time, while I'm tokenizing it, it might be trying to find out or work in respect of the definition phase of symbols too. Like we saw some warnings also in the form. How do I generate these errors then? What should I do? So in what form my symbol table, sorry, in what form my error table should be? Now I will have to have two error structures. Okay, so let us say, let me create this. So first is error table. Here, this error table will have say error number, correct, and its text. What are the text that it has? Suppose error number 2. There is again a text. So whether you are including that into double quotes or not, that is different thing. Because you are taking sometimes help of that percent C percent D kind of like so for example, here you can see it added this EZX in a single quote. Correct. So you may have to take into consideration sometimes the names declared in the code. So you may have percent S percent D included in that error too. Correct. So this is how your error table would be. Now you have to have another table, error info table. Now this table will contain say line number and error number. And you will have to have a flag. Whenever an error is generated, this flag is to be set to 1. Otherwise it is 0. So whenever you are seeing an error, that means you are adding some entry. So towards end, like before you start uh, generating or executing pass 2, you check what is the value of this flag and ultimately capture all entries from this file, from this table, from this data structure. Suppose line number 1, error number 34. Line number 7, error number 65. Now these 65, 34 are from this table. Correct. So this is what number and text or error message. Correct. Error message. So this is how exactly I can think of implementing my error table. Now, in some cases, like whenever I'm dealing with these errors, I can think of some other columns too, which probably are not included here. So say, for example, whether this message is going to have some more parameters, the way that we showed you, we saw rather symbol is ZX is undefined. So maybe it may have some additional input required, additional output parameter required. If yes, then check what is exactly it is so that you can take it at that time while displaying that error. Like when it goes to suppose line number 34, sorry, line number 1, it saw error number 34 and suppose this is error number 34, say for example. Sorry. Suppose this is error number 34. then it will pick and it will identify, okay, now when I see that there is an input required, suppose, suppose this is value to be 1 and what value is required, say it requires %s, then you should know what it should refer to, the variable. So you pick that variable, what are the variable that you wish to display. So you can have only this %s here, for example, as an example I am giving, or you have how many parameters are required to display that error. So this is a design decision to be made by you while you are displaying the errors. Correct. Now for a sample perspective, let us say we have information about your classmates like roll number 1, who is roll number 1, who is roll number 2 from MSc. Now suppose I'm picking one name, say for example Amit. So I wrote that Amit as a word in my original source file. And if it is identified that Amit is not present in this class, then ultimately it should give an error. So like if I have to generate them, what kind of errors possibly could be? So take a single sample file for your reference. You can operate on any kind of data that you may wish to work with. Correct. Take any kind of data as per your requirement and try to generate errors if at all they are there in the source. So prior to that, you need to have information about all errors that you may include in your pattern. Correct. Now, when you are dealing with such kind of stuff, then ultimately it will help that assignment will help you rather to come up with some kind of formal design for this error table and error info table. So whether will you require only one or whether you will require two. So if you see the source code of, say for example, NASM, you will see that all errors are listed through the printf statements. And it tells information, okay, what would be included and what will not be included. Correct? Depending upon what is necessary to be added there. Correct? So to operate onto this, rather, we need to have some policy defined here, which can help us to get a brief idea about how this error handling is to be done. So you can come up with your own criteria, own mechanisms, which would be helpful for you in some sense to get brief about, okay, how the errors should be displayed. Right? How the error should be displayed. Now, while doing so, you have to collect all such errors probably. You need to know on prior basis what are the possible errors those may get generated as an say for example output point of view. How many possible errors possibly could be? If those are to be included, then how exactly we are going to operate on those errors? What would be the process that we may have to apply, achieve the goal? Correct? To achieve the goal. Our goal in this case is what? How exactly you are going to deal with all these errors? What kind of different errors would be? Are you going to categorize them in some form? Correct? Are you going to categorize them in some form so that the errors can be used and displayed in some front? So those errors, now when I say categorize, some of the errors would be syntax errors, some of the errors would be parser, like the way that we saw here, warnings. Some of them would be talking about defined, undefined stuff. And that decision is to be taken on the fly. What kind of errors should be displayed here? Correct? Any question till this? If you have, you can ask. Yes, please. No questions? Okay. Now, how about the literal or the translation that would be required for elements that you have into your data and BSS section or even the code section? How will you work with such kind of uh, variables or values that may be part of the processing? Now, how exactly it will be part of processing? One important thing is when we are dealing with all such errors, all such literals, the constant values which are declared in data section for a while, if you see, okay, let me correct this error for a while, then I will show you. Now, if you see, this 10 is converted like this. This 25 is converted like this. 40 was converted like this. 28. There is no information about this, the empty. Nextly, 193 was converted like this. This a sample is converted like this. And then below, like if I see, there is nothing available in my source code. If at all, I do consider this statement. So if I write it like this, now let us take this data. Let us see this LST. Now we already have seen like if at all it is to be done with data, how exactly it is done. But what happens if we deal with the elements that are passed as argument? So 10, this 10 was converted like this. 1000 and this value, larger value, this A was converted to 61. SD was converted to something like this 73 and 64. Now, how exactly this should be done? How it will know what exactly the value has been passed by you, if at all it is to be. Correct? If at all it is to be done or implemented in some sense. Now, when we deal with such kind of elements, information about his translation. Now I can see here, look, when I see this 10 occurring in data section, it is taken as 0A. When I see it with move, it is taken as 4 bytes. But if I use same case, when I have replacement of move by, say, for example, add EX, comma 10. I will see different strategy used ultimately at that time. So this A was converted to 0A in this case, whereas it was taken like this. So how exactly I am going to consider or apply scenarios related to this? And what should be the strategy that needs to be provided or applied whenever we are seeing this instruction? So when I say 10 for few instructions which are not arithmetic one, any arithmetic operation will have some kind of impact there. How many bytes need to be used to represent that immediate value? Each of the case that you see except this NOP instruction here, all are having data provided in immediate form. Immediate form. Correct? Now, if it is the case, do I need to store information about it in my opcode table too? Probably yes. So that it will know how to operate on that value, which is added as a constant in the form when it is to be written over there. Fine. Now, when we are done with, say, for example, we operated immediate data, we operated registers, we operated on instructions. How exactly I'm going to operate on flags? Now these flags, like for example, we saw with jump if 0. There are multiple such jump instructions probably could be there. Like if at all I am using a string instruction, which we saw in one of the class, we could see that there are repeat prefixes are to be used the way that we saw while translating while making use of Intel manual. So one repeat prefix we saw was 66. Sorry, the 66 prefix was used for 16-bit data. But whereas when we have a string instruction used, one can use repeat prefixes, segment override prefixes. All of these possibly could be there depending upon how exactly you are using them. Now they might be making use of sometimes, say for example, we saw STD and CLD kind of instruction which controls execution of flag register or usage of the flag register. How the flag register would be making an impact in execution of the instruction. And what kind of impact it is going to have on each of the form. Which is playing an important role rather while you are trying to execute such a instruction. Correct. So now if I have to talk about that flag, how exactly the flag is to be used. So let us try to take one example. Yeah, let us take this. Sorry, seems it is containing. Let us write it. Let us take this example. Okay, now let us see this is E flag. Set breakpoint. Sorry. Run. Let me see the code. ECX EDX. Okay, now parity 0 and is in interrupt flag. So I don't expect you to implement maybe all of them, but at least the flags which you may use for operating on the data part. Okay, mainly. Fine. So let us see how can it be done. NI. Concentrate on E flag value, ECX EDX values too. Now you can see when we used this XOR EDX EDX, no change was made here. But when we executed add EDX comma ECX, we can see that that 0 flag was removed because addition doesn't result it to 0. So decrement ECX. This also removed parity because considering how many ones, whether odd parity or even parity was seen there. Correct? Whether odd parity or even parity was seen there. So let me write NI. See the flags. It is going to LP. So we have written it as jump if 0 to LP. It is not 0. So that's why it is coming out of the code. It is not actually jumping. Because our code was we should have written there jump not 0 to LP so that it can have a loop. But we said jump if 0 to LP. So this will never reach to that LP. So let us make the change. Let us write JNZ now. So you will see breakpoint main display dollar E flags run. Okay, let me display ECX EDX NI. Now you will see impact of the or control even. Now it is not 0. So you will see it is going back to 11. Again XOR. Your flags changed. Again NI. Your flags changed. NI. Your parity flag came into picture again. Jump not 0. XOR. Again flag change. You will see that the flag also is controlled by these instructions. So these flag actually are binary values. They are 1 or zeros. They are set or reset. Depending upon what exactly is happening at that point of time. and how exactly they are going to get operated. So these flags would be mainly used by you to control execution. To control execution of the code. Now, how exactly we can control execution? Mechanism probably would be, can we see the values and take the control, check the control, or operate on the control? Either of these scenarios would be helpful in some matter, in some part. Correct? Now, furthermore, the data that you are going to operate upon will be playing rather an important role over here. Important role in the sense, how exactly the data would be operated and how exactly you are going to control values of these flags. Now, when I say how you like use or execute control, here you are going to make sure what is the possibility or what kind of operation would be required to change value of that flag at particular time point. At particular point whenever we are operating on the data respectively. Now, can you suggest me like what should be the mechanism that should be applied to control these flag values? So what majorly you can think of zero flag. You can think of probably directive flag, direction flag, so that you can simply control execution of them rather in some form. In some form. How will you do that? What would be your logic? Because you must have see control should be passed above, like when we say decrement ECX and when it is not zero. If you see here, if it is not zero, it is at line number 14. If it is not zero, then it goes to line number 11 and this continues. So suppose it reaches that ECX reaches to zero. Let us see what happens. 3, 2, 1. Okay, now this would be last phase. Added. Decrement ECX. Now when you decrement ECX, ultimately your zero flag is into the picture. And now see what is the code which gets executed after line number 14. It is not going to 11, but it reaches to outside that boundaries of the code because it was the last statement in my code. If you see line number 14, it was last statement in my code. That means it should come out of the code. Now it is not going to execute that part. It is reaching to out of the boundaries. Going back to the addresses which are referred by my program. And this will be kind of like somehow if I have to control these flags, whether I'm going to take it as an array of flags or whether I'm going to take those to be different variables. That would be one major challenge in front of you. How should you go about? Now, if you see implementation of this flag, it is like an array of say 32 bits, where that means 4 bytes or integer array probably or character array for a while to consider the value to be 0 or 1. Correct? Now, how will you implement this array? This flag. Whether array is, do you think array would be sufficient, or you should use different variables as in a flag values? As in a flag value. What should be the mechanism that needs to be followed so as to achieve the operation execution in a successful manner? Correct? What would be your opinion? Uh, how will you decide what should be the mechanism to be applied so as to get everything executed on a proper manner such that the flag also would be taken into consideration while operating on various data elements? Fine. So give me your solutions. What do you think? What would be the better approach? Whether will you use it as an array, or whether will you go about thinking like it as an say separate variables? Yes, come up with your solutions. Which one do you think would be a better approach? Yes, please. I'm expecting reply from you peoples, by the way. Yes. Are you there?
Yes.
Give me an approach probably. Like which one do you think would be best approach for you in implementation of these flags?
Array.
Array. Okay. So why? Why an array? And why not a set of or a single variable for separate variable for each flag? Yes. Hmm? What would be advantage of having an array instead of using it as a variable or maybe set of variables, different variables?
Sir, we can search through the array which flags are active.
So if it is an array, but then you have to always reach to that particular level, because when you have to set and reset, every time you need to go to that particular stage and get the information. Okay, because you are not like you need to fix first which index would be responsible for which flag, correct? Am I right?
Yes, sir.
Okay. Then next, what? What would be next thing? How will you define or how will you decide? So whether like if you see the pattern applied by uh, the bit position, suppose if I display the flags like this in binary mode, correct? So it is showing me, that means what? I can see that there are 3 flags set right now, but there are 4 values which are 1. So probably only 3 of them are the proper positions for these flags. The position which was shown as one of them rather doesn't have any impact, because that is set because of some operation internally happening. Right. So if I restart it again, check the values. How there are 3 flags, but it can see, you can see 3 4 ones. Okay, let us go on. And when flag changes, see the value change that is happening, which was kept same. So that means this 1 was meant for 0. Okay, because see, you can see 0 flag was reset. Earlier it was 1. Now, sorry, earlier it was 1. Now it is made as 0. So there is no change in the data part, correct? Except that position for 1, the 4th position, it was made 0. Now if I go further, parity was gone. So this seems to be the parity flag. Correct? The position from least significant bit in that 32 bits. Am I right? So similarly, suppose if I add, if I create some situations because of which my flag would be, let us say, no, it is not. It is FCHS. So if I say STD, so I'm considering directional flag here. Display it in binary. Breakpoint main run. So you have parity flag ZF. Now see the number. Now when we set direction flag, you can compare the both the binary values. So if I see 0, 1, 1, 0, 1, 1. So this position seems to be for direction flag. Now later when we said again CLD, then this one should go in some point of time. So XOR, no change, CLD, that one is gone. That means what? This bit position is meant for the direction flag. Correct? Are you with me? And if it is the scenario, then fix first what would be your flags, which flags you are going to make use of, and how exactly you are going to use them. How exactly you are going to use them. Okay, think over this flag. I want you to come up with some solution which will be helpful for us rather to design our own flag register. So which you would be using for some operations to be carried out. Okay. So I'm not expecting you to take care of all flags. At least the flags which you think would be important. There is auxiliary carry, there is carry flag 2. Like for example, if you take some binary data, say for example 1000 10. Okay, let us take the scenario. Suppose take this. Okay, I hope I should have written 0xff. Sorry. So that it can identify that it is a immediate value. Yes. Display slash t dollar e flags breakpoint main run. Now move CL comma FF. Increment CL. Now you can see that there is an auxiliary carry flag came into picture. So what I did was 1000 1000. I added 1 to it. That means what? If I add 1 to it, what will happen? An auxiliary carry flag should be affected because I am adding 1 into that F. So it is going beyond that particular level. Correct. Now, which was the bit position you think now is operated? See this 1, 2, 3, 4, fifth position. So fourth bit from right side is treated as auxiliary carry. Now, when I operate on this auxiliary carry, now you can see these flags came into picture. Auxiliary carry was set yet. Now this is removed because you are operating on XOR. XOR removed that auxiliary carry. CLD add. Now we already seen these other things. So that means like this is how some of the you can create scenarios and see whether the flag value is affected appropriately or not, so as to achieve what we are expecting from the flags. Correct? From the flags. And this would be always important rather to work around these different what you can call it as flags, depending upon how the situation requires you to make use of all such flags. You can create scenarios so that the flags would be added, affected, so as to see what different flags are coming into picture. Correct? Now suppose I said add CL comma CL. Now we saw auxiliary carry earlier. Okay. Breakpoint main display slash t dollar e flags. Sorry. E flags. Then e flags run. Now you can see carry flag also came into picture. So see the position. ZF was there. ZF was removed. Auxiliary carry and carry flag both came into picture along with sign flag. Because FF plus FF, that means your 8th position from right is for changing the sign. Because it is going beyond now 8 bits. So that's why carry was generated. Even sign flag for 8 bit because we are operating on 8-bit value here. So that's why sign flag also came into picture. So now if I try comparing this data and this data, Okay, this one remained intact as it is. This one was lost. Correct. Now this one was intact. This 0 was removed. This one came into picture. This is definitely an auxiliary carry. Correct. Auxiliary carry. Now if I see the sign positions, this 4 digits, this 4 digits. So this particularly might be a sign flag. Probably we need to move around. So if I say, for example, again operate on other data, which one is gone? Right now, nothing changed. So STD, I got direction flag. So where is the change? Auxiliary carry, sign flag, interrupt flag, direction flag came into picture. So I can see that this one is added here before this one. Correct? So now if I go to XOR, now see where is the change? Direction flag intact. Correct? Auxiliary and carry, have they been removed? One can check here. This one is gone. This one remained intact. Which one was same among these? Direction flag and interrupt flag. So if I say that this is interrupt flag for me, because it was earlier 2. Direction flag was not there, so I assume that this is direction flag, so it was kept intact. This one is gone. This was for auxiliary carry. It's gone. Moreover, if I see 1, 2, 4 plus 4, 8. 4 plus 4, 8. So this got changed. So sign flag also gone. Correct. So create the scenarios probably and find out what are the different positions. So if you search about flag register in IA32, you would be able to see that in the manual or probably on Intel website, how the flags are organized. So try to think of them, try to implement some of them, rather some of them. I don't expect you to all make use of all. You can think of an 8-bit flag value, flag register. No need to take into consideration 32-bit flag register.